Now we are going to discuss about the Numpy. So Numpy is a linear algebra library for Python, and the reason why it is so important for data science is that it covers almost all of the libraries in the PyData ecosystem which rely on Numpy as one of their main building blocks. So one more thing, one more advantage we have, Numpy is also incredibly fast as it has bindings to the C libraries. For more information, why would we use the arrays instead of list, check out the entire video. Okay, so first we are going to talk about the installations process. So to do that, if you are using a Jupyter notebook, you just need to do conda install numpy, and you can see this that by using this conda install numpy, your numpy will be installed. Or if you are not using Jupyter notebooks, so simply go to your PowerShell and just do pip install, right? Pip install numpy, right? As your numpy is installed, now you need to do to import it in your program. So to do that, you just need to do import numpy as np. So Numpy has built-in functions and capabilities, and we won't cover them all, but instead we will focus on some of the most important aspects of Numpy, like vectors, using arrays, matrices, and number generations. So let's start discussing by arrays. So Numpy arrays are the main way we will use Numpy throughout the course. Numpy arrays essentially come in two flavors, like vertices and matrices, and vectors are strictly 1D arrays and matrices are 2D arrays. So how to create the Numpy arrays? Just now we have talked about, if you have seen my Python playlist, go and check in my video, you will find it there. So we have seen how to create such lists. So this is the way we are going to create a list, right? So this is my variable list name of my list, and here I have three elements, okay, 1, 2 and 3. And if I just do my list right over here and do shift plus enter, it will give the output 1, 2, 3. Okay, so now the same thing I want to do, that I want to create an array and I want to convert my list into my array. To do that, you just need to do np.array, right? So this is the feature which we are going to do, np.array. Why np? Because we have imported numpy as np, so np is the short form for numpy, so that's why we are using np.array, and inside this parenthesis we will pass the parameter of our list name, so which is our my list. Now you can see the changes, you can see the differences between these two. First, when we execute the list, it shows 1, 2 and 3 with the square brackets, but now it shows with an array written over here. Array is also there, and you can see the parenthesis, and inside it we have the list. So now my list has been converted into my array. So if you do that with your matrix, like another example, I'm taking my matrix and taking it 1, 2 and 3, 4, 5 and 6, 7, 8, 9. So these are the three lists which I have included, nested list. Basically this is a nested list, and if you run that, you will see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our execution of our nested list, right? Okay, just move ahead a little further. We will see that if I do the same thing, same function like np.array, and write inside the parenthesis my nested list name, so my list, and you will see that it has been converted into an array, just like this one, 1, 2, 3, then 4, 5, 6, 7, 8, 9. So basically it has 3 rows, right? 1, 2, 3, these all are the 3 rows, and it has only single column. So this is my entire column, only one column. So it has been converted into my matrix form, right? Let's talk about the built-in methods, and there are lots of built-in ways to generate the arrays. Like the first one which we are going to discuss is a range. What does it do? It just returns evenly spaced values with a given interval. Let's see the example, right? So this is my first one. I have done that np.arange from 0 to 10. So I want to include elements starting from 0 and it will ending till 10. So just keep this thing in your mind, that whenever you are giving a stop parameter, so it will stop, it will terminate as soon as it finds the 10. So it will go up till the previous value of your stop parameter, right? You can see here it has started from 0 and it has ended in 9. So similarly, now we have another thing. just np.arrange, and now I am getting another third parameter, which is our step parameter. So this third parameter is my step parameter. Okay, so this parameter does what, that it jumps to what step you want to do. Like first, earlier we have not mentioned any third parameter. In my last example, my previous example, you can see that it has been growing up with a increment of 1, but now you have given a step parameter and it is been located with a value of 2. So now it will be growing with a 2 step, right? So you can see here, now we execute this code, then you will find that 0 2 4 6 8 10, and see, you have terminated at 11, so it has been terminated with a 1 previous value. So your array has been executed starting from 0 and ending to 10. Okay, you now want to create zeros and ones. You want to generate arrays of zeros or ones, right? So to do this, you need to do simply just np.zeros, and the number of zeros you want in your array, just give the value. So over here I have given 3. So now you can find that your array has become with the 3 elements of 0. Okay, so if you want to build a 2D array or 2-dimensional array, the first one over here we have only one parameter, so it is defining only your rows. You don't have any columns. But in the second example, we can see that np.zeros 5, 5, right? So 5, the first one is for my rows and the second one is for my columns. You can find there are 25 elements right now in your array, and it is including 25 zeros starting from the row 1, row 2, row 3, row 4, row 5, and there are 5 columns as well. So this is how we can create zeros. We can generate arrays of zeros and ones. So simply, as we have seen that how we can create the zeros, so similarly you can also create ones, right? So np.ones, see the same example I have done. Now 1 is created in your array, and there is another of 2D arrays, so 3, 3 rows and 3 columns. Now you can find these 9 elements, right? So why there is a function of 0 and 1, because there are some functions where we need to know whether it is true or false. So 0 resembles our falsy value and 1 represents our truth value. That's why we have this function of zeros and ones, how to generate zeros and ones, right? Now we want to see about the linspace. So it returns evenly spaced numbers over a specified interval, right? So let's look about this example. np.linspace. So what does it mean? Linear space. Linspace means simply meaning linear space. So I will tell you what is the difference between our range and linspace right here. So okay, now I have given a start parameter of 0 and my ending parameter is 10, and this 3 is not my step parameter this time. Okay, this is the number of elements you want in your array, right? So from 0 to 10 I want only 3 elements, and it should be equally, or it should be evenly spaced, right? So you can find the difference between if you execute this, you will find that 0 and 5 is there, and then 5 after, then we have 10. Okay, so the difference between 0 and 5 is equal, and 5 and 10 is also equal. So your array has been divided into 3 equal parts, right? So another example, just see there, 0, 10 and 50. Okay, and over here it doesn't mean that it is your row or column, right? It is your start parameter, then stop parameter, or the value stop parameter, and third one is the number of intervals you want to divide it, right? So over here we have 50 for that, and this stop parameter, I have told you that in our range it doesn't go to the stop parameter, it terminates one value before, but over here linspace does what, it takes the last value also, which we have included. So you can see this array, it has been starting from 0, 0.204, 408. So you can find that with every value you will find the same interval. Okay, it is evenly spaced, right? So this is what our linspace do. Let's check out with the EYE. So EYE creates an index matrix. You have heard about what is an index matrix. So if you do np.eye, you will create an index matrix. You can check that this is the all your diagonal values has been 1 and the rest values will be your 0. Let's now talk about how to create the random value. Okay, how to generate random numbers. Okay, there is a module named random in our numpy. In our numpy library there is a module having random. So this random has many features like rand, 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 and lots of. So we are going to discuss it one by one. So just look to this first one, right? So create an array of the given shape and populate it with the random samples from a uniform distribution over, right? So now I am having np.random. So you need to do this random module. You need to call this random value because rand and is a function of this random module. So you need to call this. You cannot do it just by np.rand. It will not work. You need to do this np.random.rand2. So over here I pass the two parameters. So what does it will do? It will generate two random values, but keep this thing in your mind that it will generate between 0 and 1. It will not exceed from over 1, or it will not go below 0. So it will only generate values between 0 and 1. So now you can check. I have created to 25 elements by giving 5 rows and 5 columns, and here you can watch there are 0, 1 to all the values which has been between 0 and 1 interval. Okay, fine. Let's talk about the rand and function right now. So it returns a sample from the standard normal distribution, unlike rand which is uniform, right? So what does it do? Rand is a uniform, rand was uniform, and it is not uniform, right? Okay, so if you do that np.random rand, so it will also generate values. It can be negative and it can be positive, right? It can take any values. It is not that it will only take values between 0 and 1. It can take any value, whether it will be negative or it can be positive. So same thing it does. Okay, so now let's talk about the rand int, right? Let's now discuss about some array attributes and methods. Okay, so the first one we are going to do is we have seen that rand int, how to do that. So now we are going to talk about the reshape method. So if you want to change the shape of your matrix, you want to convert your rows into columns or your columns into rows. So to do that, you just need to do reshape. Okay, there is a function known as reshape and it will do your job. So similarly, just I want to show you with some examples. There are another methods also, like max method. Okay, this is the methods max, mean, or your argument max, argument mean. So these are all the useful methods for finding the maximum or minimum values. And this arg max and arg mean does what? It just finds the index location of your maximum value or your minimum value, right? So you can see here the first example I am taking just as RANARR, right? So this is my array elements 10, 12, 41, 17, 49, 2, 46, 3, 19, 39. And now I want to find the maximum values out of this array. So you will see that RANARR, the matrix name or the list name or your array matrix name, and dot max can do your job. So it is 49 right here. And if you want to find the index of your maximum value, just do that dot arg max, and with the parenthesis it will give 4. So check the index. So 0th index, first index, second index, third index, and fourth index, and 49 is the highest value over here. So it returns the index of your highest value, right? Similarly, if you want to find the ranarr.mean, so it will give you a minimum value. Okay, so and to find the argument, so with the arg mean, it will find the index of your minimum value. Okay, so let's talk about something other. Now we are going to talk about the shape. So shape is an attribute that arrays have, right? So if you want to check the array, like over here I have taken an example of this vector one, arr.shape, right? So if it gives a shape of 25, because we have 25 elements on our row, we have no columns right here. So if you want to change it, you can just arr.reshape into 1 to 25. Now it will be converted into 1 row and 25 columns. Okay, so 25 columns. Now you check the shape of that arr.reshape and just do dot shape with it. So you can find it that it has been converted from 25.0 to 1 to 25, right? And if you want to check it, let's check it. So another feature we have to know the data type the type of data which we are having in our arrays. So to do that, you just need to do arr.dtype, right? And you will find what kind of integer or what kind of data is there. So we have the integer values over here. So 1, 2, 3, 4, 5, 6, all our integers. So you can find there that this is D type is our integer dot 64. It is returning an integer type 64-bit number value. Okay, so that's the video of our numpy arrays. So if you like this video and if you find that the content over here is beneficial to you, just do like, share, subscribe my channel. If you are new to my channel, just go and hit the bell icon so that you get the notification as soon as we upload a video. Thank you guys, take care and see my next video.